Hello everyone, I'm the CEO of RDX Works. I'm here with Josh, who's one of the main developers of both the Radix engine and Scripto, and has done a whole bunch of stuff in the Radix consensus. He's been with us since right near the start, and so it's a real pleasure to actually get you on the couch and be able to talk with you about all of the things that we've been doing. And so what I wanted to do was get a little bit more insight into, I think, the Radix engine, right, first. And then how that's eventually fed into how we've been thinking about Scripto and building Scripto. So, take me through how did you first, where did the idea of the Radix engine first come about?
So Radix engine came about when we started building out Radix. When I first joined, we had a very simple, transaction model with the original consensus, basically just sending transactions of tokens from one user to another. What we want to do with the Radix engine originally was make that a bit more generalized, so that you could do more smart contract type things, and do almost any type of contract that you'd want to write.
Right.
Very similar to what Ethereum does.
Right.
The big challenge for us was that we wanted to use the UTXO model.
Yeah. Okay.
Which is, you might be familiar with that with Bitcoin, uses the UTXO.
Right.
And the nice thing about the UTXO model is that it provides a very structured way of thinking about, I guess what you could say is states, or how things live on the blockchain. And it's actually what allowed us to think about how we can massively parallelize consensus, is if we have this very structured way of thinking about state, which is what the UTXO gives us.
Right.
The bad thing about the UTXO is that, at least up to that point, you couldn't really have a very generic way of programming that. So we wanted a way to have the power, the expressibility of what you see in Ethereum.
Yeah.
But the structure of the UTXO.
So what do you mean by structure? What's good about the structure of UTXO versus what Ethereum uses, which is the account model, right?
Right. Yep. So with the UTXO, the structure is in the it's in the way that you're very explicit about the states you need.
Right.
About the dependency chains that you need to make your state transitions, and that's actually one reason why Bitcoin is so safe, so to speak, is because these state transitions are so well integrated into the UTXO.
Right. So Bitcoin is safe because I suppose you're asking to do something quite powerful, i.e. send one token to another, let's say one token from one address to another. You're actually specifying a very simple set of logical steps, right? You're basically saying, right, these inputs are being spent to this output, and you're being very specific about what you want to change as the state of those, and once they've changed state, you can't go back and change the state of them, right?
Yeah, exactly. So it's more of the fact these UTXOs can only be spent once.
Yeah.
Right. So as opposed to the Ethereum model, where you have these addresses, and they just an address represents some data under that address, but the way you manipulate that address can be done many times.
Right.
And so it's a very different model from the UTXO, where there's this one thing that can only be spent once.
Right.
And with that invariance, that constraint on the system, you can make further assumptions at the consensus layer to be able to do parallelization and other types of things.
Right. So with Ethereum, I'm kind of going, oh, I've got a bucket of tokens on my account, right? And there's 1,000 of them, and I go, right, I want to send one of those tokens here, and then someone else says I want to send one of those tokens there.
Right.
There's a bunch of extra logic that has to be there going, well, do I still have enough tokens? Is the balance still above zero? Mm-hmm. Whereas with UTXO, it's very clear. You're going, that input I want to spend, and either I can spend it or I can't spend it, but you're not like doing secondary checks of going, is there enough balance here or anything like that?
Yeah, exactly. So if we go deeper in that example, with Ethereum, you've got that balance of 1,000.
Right.
I need to subtract one or whatever amount you're transferring, add one to the balance of the other person. So that's the way you would construct that transaction. Minus one plus one. But the problem with that is that you never know where that original 1,000 is from.
Right.
Whereas with the UTXO, it's like you're actually, this specific state, this version in time, you're manipulating that. And then after that, it's a different version. And so
it's really interesting to see how like full circle these engineering decisions have gone, right? Because we started with Bitcoin and everyone was like, oh my God, UTXO, really powerful, really clever way of managing state for transactions. And then Ethereum and the account model came along and they were like, well, this is much more simple to think about from a conceptual point of view. But now you're starting to see it coming back again, right? Like Cardano is UTXO, but then there's a bunch of problems with that as well, because if you have a smart contract, let's say you have a Uniswap smart contract, and that Uniswap is, I come to it as a user and I say I want, sum of tokens X in exchange for sum of token Y. I don't want to have to, as a user or as a light client, have to specify which UTXOs I want, because if I go, I want those ones and it's contentious and someone else says, I want those ones too, and it fails, not because actually the swap would have failed, it fails because we've both gone for the same UTXOs,
yep.
which is one of the reasons that Cardano and Plutus is so not user-friendly for DeFi. Right. So how have we managed to square that circle? Like, how do we get to the point where we can have this incredibly structured way of having, state transitions with UTXOs that are able to scale massively and in parallel, but not like create all of this complexity for the developer and the end user?
Right. Yeah, that's a good question, and it's the one thing. One of the main, I would say, big things about Radix and your V2 is solving that exact problem,
right,
with UTXOs and contention over it. Because, like you said, UTXOs were really meant for on state where there's no contention, where each account kind of owns their own thing. They know nobody else is going to spend it because they own it.
Right.
When everybody's trying to gain access to that same thing, and then you've got big problems like Cardano. And the way we've thought about solving this is adding another, say, layer of abstraction on top of the UTXO model.
You love a good layer of abstraction.
Yeah. So another layer of abstraction on top of UTXO. In this case, you can think of this as the consensus layer, or the validators in a way. Where you as a user, you specify this set of UTXOs that I want to be able to spend in a way, and then you leave it up to the validators when they're running your transactions to deterministically determine which of those in that set you're able to spend.
Right.
So you're kind of offloading the burden onto only during execution time, right, rather than off-chain time.
So you're basically going, I would accept any of these as part of the transaction, but I have some logic to say only up to this amount, sure, right? Mm-hmm. And then it's the node runners that then decide which particular ones of those are going to make part of the transaction, which means that if you have a highly contentious set of UTXOs, if the node chooses what consensus happens in what order, and so then they go, okay, right, well, I'm going to do this set of UTXOs for that user, and then this set of UTXOs for that user. They've got an overlapping set, but they don't want to have. They're not actually using all of them. They're only using a subset of them. As in the output, they are happy with a subset of them, which means that you can have swapping, right? Where yep, you as a user, you're just going, oh, I want this token X for this token Y, yep, and I'm basically specifying everything that's in the pool as potential.
Exactly. Yep.
But then my output is specified within a range so that I get the balance out that I want, but you still have that highly structured UTXO from the consensus point of view.
Yeah, exactly. I mean, another way to think about it is that in our model, essentially, It's only the execution layer, which is really exposed to the UTXO model.
Right.
And transactions are basically intent, so it's very Ethereum-like in that you only specify, even at the scripto level, you're only specifying sort of the intent that you want to do, and then underneath it's the execution layer is the one that's doing the UTXO manipulation type stuff.
Right.
In this case, in this way, there's never any contention at all.
Right. And so this is different from the Radix Engine V1, which is currently running on our Olympia network. And so the Radix Engine V1 is like you directly, the client directly chooses the UTXOs.
Yep.
Right. Okay. And so what were you trying to? What's the set of features or benefits that you were trying to prove out with the Radix Engine V1? Like what was that like design paradigm, like MVP target?
So that one was more of a how do we generalize the UTXO model? And I mean, this has already been done by Cardano around the same time we did it. But how do we make a UTXO model so that it could support arbitrary types of logic? With Olympia, we didn't have to deal with any sort of contention issues, like with swaps. So that was no problem. And so we were able to, with Olympia, you can create your own tokens, have different rules on each token, staking. All of that logic is done through a UTXO model in a somewhat performant way and general way. So that's what we want to do.
So obviously UTXO stands for unspent transaction output. Like what should this be called?
We've been calling this substates.
Substates.
Yeah, so essentially you can think of this as like a state in your a partial state of your world that makes sense on its own, and so you could like essentially like a physical token. Like this represents something, but you can move it in this world in any way throughout space. That's how you can think of like these substates.
Right. Yeah. Okay. And so the other thing that has come along with Radix Engine V2 has been much more generalizable logic as well, right? So can you talk about like what we learned from Radix Engine V1 and how Radix Engine what has been done with Radix Engine V2 to enable things like Scripto?
A lot of the making a UTXO model generalized is quite difficult. For example, with Bitcoin, you've only got one sort of substate or UTXO, whereas in ours we have to think about how do we represent any generic substate? How do we serialize these? How do we represent these? So those sorts of things come into play when doing Radix.
Okay. And so talk about Scripto and how Scripto interacts with the Radix engine, because a lot of people sort of ask questions about whether or not Scripto is Turing complete, and obviously there's some elements of the primitives that we provide that aren't, like the representation of a token, the representation of an NFT. So just talk about how you think about Scripto programming language and then how that interacts with Radix Engine V2.
Okay. So one way to think about it, so with let's see, how do I describe this? One way to think about it is that Scripto gives you a Turing complete language. So what does that mean? That means I can express things in the way most programmers know how to express things. And you do this through a WASM environment, which gives you full Turing completeness.
WASM being WebAssembly.
WebAssembly, yeah.
What does the whole thing stand for? WebAssembly?
It's just WebAssembly.
Oh, is it just WebAssembly? So
Web ASM.
Okay. Web ASM. Okay, fine.
Yeah, Web ASM. So that's allows you to manipulate almost anything, very similar to Ethereum style, in this thing, in this manner. The other big part of Scripto is the resource model, the asset model,
right?
And this is where more of the where we get the safety of the old UTXO stuff in there. So with Radix Engine V1, one reason why we wanted to keep use of UTXOs was implements that finite state machine that you might have seen with we've talked about finite state machines and how different assets can move from one place to another in a very controlled way.
Right.
These are the only states that these assets
Yeah,
can
I mean,
be in.
I love your analogy that you talk about when talking about the finite state machine is using Pokemon.
Pokemon, yeah.
Right, where you're like, you have a Pokemon and it evolves, but it can only evolve from it can only do one step at a time,
Right.
and if it's in a state like it's like knocked out or dizzy, what's the like has fainted. If it's in the fainted state, then it can't go into any other state than the unfainted state
until it goes back.
and then it can only go one step at a time. So it can't go from like Squirtle to Warturtle. It has to go to whatever the one in between is. So this is like super powerful because there isn't such thing as getting into the wrong state. You can't go from Squirtle to Pikachu.
Right. And with that sort of mental model, another powerful thing about it is that it's very easy to model and think about the whole range of possibilities of your system, because it's finite. You can think about the whole thing in a very finite set of states.
Right.
Which
I suppose makes it easier to also assure yourself of the security of the system as
exactly.
well.
Yeah. And so we sort of have that same thing with tokens, but it's changed a bit with Radix Engine V2 in that that idea of FSMs on resources has been moved to a more resource model where a resource can move into what we call now vaults. If you've seen Scripto, you've got vaults in components. They can move out into buckets, and then you can turn those into different bucket refs and that sort of thing. So it's actually still its own state machine. It's just now a little bit more generalized for the Scripto world.
Right.
And so we retain a lot of the safety that we had with Radix Engine V1 with respect to like tokens and resources, which is the most important part of DeFi.
Right.
So you can think of it as is a very highly constrained part of the system, which has very strong rules.
Yeah.
But then you have this Turing completeness outside of it, where in the Scripto world, where you can manipulate those resources in whatever way you want to express those resources in your component or smart contract.
Yeah, I think this is a really clever and powerful set of concepts because Matt talks about this with the idea of like business objects and actions. Like the business objects are your assets and resources, and you want those to be safe as possible. Like the representations of them, you don't want them to be messable about with. That they are a subset of like features that you can make very expressive, but still within this idea of they're like physical objects. They can only act in a certain way. Once they've been defined, they can only stay in that definition unless there's some like substate of set of things that are allowed to be. But you can model basically everything that exists in finance, everything that exists in the physical world of commerce within this sort of like very complete state model that still creates huge security. But then what do you want to do with those things? What's the business logic? That's when you start to get incredibly expressive, and you can't say, well, it's only a set of things. You can say, well, it could be anything. Like we can't envisage all of the ways in which people are going to want to program these business objects. So the business actions, you want to be as expressive as possible, as complete as Turing complete, but you don't want the assets themselves to ever have security issues around the actual state of the asset, what the asset is represented as. And I think this separation between these two concepts is a beautiful example of how you can leverage both. If you're clear about what the utility of both is, you can leverage the power of the FSM versus the power of Turing completeness without creating a load of vulnerability in the system.
Yeah, exactly. And I would also say, like, aside, I would say it's perhaps lucky that it's in this way, but the fact that we do have such a strong rules for that resource is actually what allows us to be able to shard in the first place.
Right.
Because everybody knows how the rules of this thing, and so you don't really need to come to agreement with what this thing will do, because everybody knows that's an inherent rule of the system itself.
Right.
I sort of almost think about it like almost in the physical world, where you have a physical token that's bound to laws of physics, which we don't need to agree on that because it's part of the world already.
Right. Right.
But with that coin, you could do whatever you want with it.
Right.
Yeah.
As in, you and I could agree the most ridiculous set of like things between us, but at some point the coin is going to pass or not pass between us, and that result of all of that like crazy logic and like maybe completely qualitative, right?
Sure.
You make a better meal for me, or I make a better meal for you.
Right,
That's not objective,
Right.
but like we will both decide, come to an agreement, and then at the end of it, money will pass. But the rules around that money are very fixed by the laws of physics. Like
Right.
either you own it or you don't.
Right.
Either it's in your possession or it isn't.
And then from a sharding point of view, it's like that same coin works from here or in China, or
Right.
everybody knows this is the rule. So that's why like sharding works, because everybody knows how these things work.
So like as we're building out the Radix engine and Scripto, is sharding always something that is sort of like at the back of as part of the conversation?
Oh yeah, I mean it's because we are thinking sharding is always one of the main things we think about. Just because, as we build out the system, we don't want to. I think a big problem with today's chains is that sharding is usually an afterthought, and that when you do it in that way, you can easily run into dead ends if you don't architect it with sharding in mind at first. And that's what I think you see a lot with a lot of the chains today,
Right.
Especially because they handle states so generally. I mean, the key address or account model kind of programming style is very easy to think about and very well known, but attaching sharding to that after the fact makes things really difficult. It's very similar to like CPU and GPU programming,
Right.
where it's like a totally different mental model that you need when going from one to the other.
Right. Which is interesting. Interesting you pick that example, because that's literally something that you did back in the day, isn't it?
Which one?
GPU programming.
Yeah, I mean, I used to work at NVIDIA, but I did less GPU program, more of the driver level stuff.
Yeah.
This stuff.
But so basically, everything that we're building is towards this roadmap of massive shardability and massive parallelization. So like everything from the Radix Engine v2 to Scripto, all of this kind of stuff is built around this idea of how do you ensure you can get to a parallel processing network that is able to do the majority of stuff in parallel, whilst it guarantee that anything that is contentious or anything that is related is still processed sequentially.
Yeah, exactly. Yep.
That's really awesome. It's really awesome. Josh, it's been such a pleasure talking with you.
Yeah, totally.
Thank you so much for your time.
Yeah.
And let's do this again.
For sure. Yeah, sounds good.